start with a little bit of context since I'm coming from Belgium. It's not very like not a lot of people knows about this little country, complex country. So as Prudence said, I finished my master's degree in 2015, and I'm part of this next generation of architects for whom durability and passive house standard is part of the education program. That's what I want to say. And I had about 300 hours of dedicated for that during my 5 years at school. I've never worked on a project that is not passive house, which is very unique here in the States. I'm proud of that. And the reason why passive house was part of my education program is because since 2015, passive house standard has been mandatory in Brussels for new buildings and for renovations. So the number of passive house buildings increased exponentially the past 10 years, I'd say, and especially in Brussels. Today, you can see all kind of buildings, all type of programs that are passive house in Belgium. It's very inspiring. And they all look very, very different. You have Jean Nouvel here, which is the tower for the police headquarters. You have the parliament here of Belgium, of Brussels, also a very, very unique building. And we'll soon have a prison that will be passive house, which kind of funny. When you think about the buildings in the States that are passive house, they are very fancy buildings, and we're gonna have a prison. It's just thought it was unique. Sebastian Moreno, the founder of A2M, started designing passive house buildings 21 years ago. And so with this long experience, we passed the point where passive house standard is standard. It should be, and mainstream and accessible to everyone. Our team is composed of engineers, and we start the energy analysis of each of our project at the conception phase, and this helps a lot to keep the cost as low as possible. Today, A2M has 3 offices, one in Brussels, one in Lisbon, and the New York office that I manage. I'm in New York right now. For tonight, I wanted to focus on 2 retrofit projects because retrofitting is going to be a big part of our job to be able to improve our cities. And with COVID and the working from home situation, I'm sure a lot of office buildings will have to be renovated and into apartment buildings, probably. The first project I go over with you is les balcons in French, the balconies in English. It's a renovation of a former office building from the 80s to 92 apartments with office and retail spaces on the first floor. We managed to keep the cost at $115 per square foot, which is very close to the benchmark for business as usual in Brussels. And we estimate that the building is saving around $64,000 in energy cost per year. So that's a very good argument to show to clients who don't want to build passive house because it's too expensive. I mean, the cost, the energy savings is pretty big. And this is the building before renovation and after a little passive house touch. I'll show you a little video. So we started this project before the passive house city law was passed. So because of this, we had to convince the client to reduce the environment impact of the project by 90%. And we were able to reach that. The biggest challenge was to manage solar gains in our favor. So we decided to integrate continuous balconies on the south facade. Most of the apartments are facing south, and if not, they have double orientations, east and west. which helps a lot for natural ventilation, of course, in the summer. And because of the shading devices, the balconies, and natural ventilation strategies, there's no need for mechanical cooling for this product. It's also the climate in Brussels, which is very similar to Seattle. I don't have time to show the whole video, but here you can see the large continuous balconies here, and they are all along the facade, and you see also the apartments are double oriented or triple sometimes, which also allows a very good natural lighting. So the continuous balconies helped to reduce the solar heat gain during the summer. As you can see here, we dimensioned the balconies. So in the summer, it would block the sun, and in the winter, it would allow the sunlight to get into the apartment during the winter. This is the bare existing building, and this is during construction. So we added some extension on the side of the renovation. We decided to go with outward insulation since we didn't want to keep the facade, the very ugly facade wasn't necessary. And we play with the insulation to create diagonal cutouts in the facade. So the punch windows are a different style. And this is the detail that we do. As you can see, we have a airtight membrane here in blue, and the plaster inside is provide the airtightness. You can also notice that we aligned the frame, the window frame, on the bearing wall, which is typically not what we're supposed to do, because it's better if the window is cantilevered, but we use a little trick. So here in the A detail is what you're supposed to do. You're supposed to suspend the windows so it's the insulation is continuous with the frame. And the C value is great, 0.0035. In detail B is the worst case, when you put the window frame on the bearing wall, and so there is a thermal bridge. It could be worse if the insulation wasn't overlapping the frame, but still not great. The C value is 0.021. And the detail C is much better and very cheap, much cheaper, but not as cheap as it could be. We're using peristyle, so you put the window frame on the peristyle block, but we decided to do something even cheaper, and it's to use just light aerated concrete blocks underneath the window frame. So we ended up with a C value of 0.016, which is clearly still a thermal bridge, but we consider it into the energy balance of the building. And we use the same aerated concrete block for many details. Just like the parapet, instead of wrapping the parapet around with insulation, we prefer to thermally block the parapet with an aerated concrete block, and it does the trick. The other substantial thermal bridge was, of course, the balconies. We used steel frame wrapped with rock wool and EPS covered with Trespa wood panels veneer. Here's a detail. So, yes, you can't see all of it, sorry. So in this detail, you can see here the mineral wool, the rock wool with the EPS. The shading device is outside the envelope, and it's hidden inside the insulation. And there is a thermally broken piece of plastic shim plate here that helps to thermally broken the envelope. And we chose a mineral wall here because for fire restriction. So this is one of the typical documents that we always share with the general contractor. So there's no confusion on what type of insulation to use for different areas of the project. They just look at the paper and they know. This is the interior before renovation. And as you can see, the radiators were taking up a large part of the wall area. And now we eliminated the radiators and increased the window size, allowing more natural light. So more heat gain too, natural free heat gain. During the construction, we always integrate thermal images to make sure that the temperature changes are homogeneous. And so we can check that with the general contractor, and if there is an issue, we can take care of it with him. It wasn't a surprise that the biggest energy loss is through the windows, the ventilation in green here, and the external walls, of course. We ended up with a blower door test that passed with a 0.52 volume per hour. And the building was Passive House certified in 2020. And we decided to divide the building in 5 blocks for certification. First, we thought about doing it by apartments, but it was a little tricky for the certification, much harder to get the certification if you do that. So the only downside about the block situation is that the primary energy was much more because of the ventilation rate, what had to be higher. The second product that I wanted to go over with you is our new project Marnix. We are working on the renovation of the ING bank headquarters, which was built in the 60s by A2M, the American. And it became a very important building in Brussels. It's a landmark and it's protected by the city. So for this project, we have to keep the facade and work with inward insulation. And we wanted to go further than Passive House and reach carbon neutrality. We have been working with our think tank, FAST, on a carbon calculator. To reach carbon neutrality, we first had to evaluate and understand what we are reaching for. So we first evaluate the standard emissions of the building as if it was built as business as usual. So we can understand what we have to compensate. And with that number, the 4,500 tons of carbon equivalent per year, we didn't know what should be compensated here, and which can be a huge amount of carbon credits, or we can try to reduce the compensation in other healthier ways. And one of the healthier ways is, of course, to reduce the carbon footprint with Passive House principles and smart design adapted with the environment. For this project, we start with a building with a heating demand of 41 kBTU per square feet per year here, and an envelope that has condensation. So really, I mean, not passive at all. And we are reaching for 3.8 kBTU per square feet per year. Because we want to keep the original facade elements, we decided to insulate from the interior, but we didn't want to increase the budget by cutting out the floor slabs and integrate insulation between the facade and the slab. So we went for insulating the exterior slab here and the interior slab. So it's not continuous. The insulation is not continuous, but we eliminated the condensation that you can see here. So here's the detail. Again, we're working on it, so it's not. We just deposit the permit demand, so we're not completely there yet, but it's in the PHPP. It's working right now, and so here the installation won't be visible because it will be tucked underneath the flashing here, and we are adding a flooring soffit where the ventilation duct will be hidden, and the installation inside will be hidden too. Working with solar analysis also increased the performance of our calculations. We use Rhino and Grasshopper to do so. And to decrease the carbon footprint of the building, we also work with EcoBat, which provide calculations and numbers about the life cycle analysis of each of the materials that we will use. And it's a software that is accessible online, so it's European, I believe. So yeah. For this project, we are able to keep some of the windows because they were replaced in 2011. But the U value is 0.3, which is far from perfect. We keep them and maintain them so we can lower the carbon impact of the building, and it will be taken into account in the PHPP. So we are increasing the insulation in other areas, so we are able to keep them, and also change the windows. The windows that are too old and where I forgot which year, but the other windows are really bad, so we have to change them, and we'll change them to triple glassed windows with 0.14 PTU per hour per square feet per Fahrenheit. And we also adding a lot of solar panels on the roof. We estimate that they will decrease the primary energy by 13%. And here you can see in the section that we also it's part of the project is also to make sure that the appearance of the building stays the same. So it was very important for the city that these PVs will be hidden and not visible from the street. That's another element that is kind of like I would say high tech, but it's not, because it's just the coating that you add on facade. Because the building is next to a high-speed road, so we are implementing a photocatalytic paint on the facade to capture the NOx in there, and the NOx is produced by fossil combustibles, and this coating is transparent, and it is composed of titanium dioxide, which, when combined with oxygen and light, it transforms the NOx into salt. So the building kind of acts like a tree. And with all these strategies, we can reduce the compensation by 74%, and the 26% left will be taken care of with carbon credits every